Hey everyone, I was thinking, what is the absolute coldest temperature that's even possible in the universe? Today, we're going to go on a pretty wild journey, all the way from that ultimate, absolute cold to the fiery heart of a star. Let's dig in.
So let's start with that big question. What is the coldest anything can ever be? It sounds simple, right? But that one question takes us right to the very edge of physics, to a fundamental limit of reality itself.
But, before we can find the bottom of the temperature scale, we got to make sure we're all speaking the same language. Because, well, there are three main ways we talk about temperature. So let's do a quick run through.
Okay, so first up, you've got Celsius. Most of the world uses it, and it's super logical, right? Water freezes at 0, boils at 100. Simple. Then there's Fahrenheit, which is common in the US, where water freezes at 32 and boils at 212. And then there's Kelvin. This is the one scientists absolutely love because it starts from a much more fundamental place, and we're going to see why in just a second.
Now, this is a really important point. The size of a degree is different depending on the scale. A 1-degree jump in Celsius is the exact same amount of heat change as a 1 Kelvin jump. But a Celsius degree is actually a much bigger jump, almost twice as big as a Fahrenheit degree. That's super crucial to remember when we start talking about these massive temperature swings.
And hey, here's a great little piece of trivia for you. There's one magical point where Celsius and Fahrenheit actually meet up. -40. Yeah, at that exact temperature, it doesn't matter what scale you're using. It is just ridiculously, unbelievably cold.
All right, so now that we've got our scales figured out, it is time for the main event, the search for absolute zero. This is the ultimate, unbreakable limit of cold in our entire universe.
So what is absolute zero? It's way more than just really, really cold. See, what we call temperature is actually just a measure of how much atoms are vibrating and zipping around. So absolute zero is the theoretical point where all of that motion slows down to its absolute bare minimum. It is the true bottom. You just can't get any colder.
And on that scientific Kelvin scale, this ultimate limit gets a beautifully simple name: 0 Kelvin. That's it, the starting point for everything.
Now, just to put that in perspective for you, 0 Kelvin is -273.15 degrees Celsius. I mean, think about the coldest winter day you have ever felt. That is like a warm summer afternoon compared to this. It's just nothing.
And listen, this isn't just a theory or a good guess. This is a hard and fast rule of physics, a law of the universe. Nothing, absolutely nothing, can ever be colder than 0 Kelvin. It is the end of the line.
So you might be wondering, what about deep space? Is it at absolute zero? Well, it's incredibly close, but not quite. Turns out the empty space between galaxies is filled with this faint afterglow from the Big Bang. It's called the cosmic microwave background. And this ancient echo keeps space at a pretty chilly 2.7 Kelvin, just a couple degrees above that ultimate cold.
Okay, so we've officially hit rock bottom. Now let's blast off in the other direction and take a super fast tour of the incredible, mind-blowing temperature extremes that we can find both here on Earth and way out in the cosmos.
Let's start with something we all know really, really well. 37 degrees Celsius. That's about 98.6 Fahrenheit, right? The normal, healthy, happy temperature for a human body, our baseline.
Okay, now let's take a giant leap down to some extreme colds that we can actually make right here on Earth. Liquid nitrogen. You see it in medicine and high-tech computers, and it boils at a frigid -196 degrees Celsius.
Now let's swing all the way to the other side, serious heat. If you wanted to melt a solid bar of gold, you'd have to crank up the furnace to a scorching 1064 degrees Celsius. That's when it finally gives up and turns into liquid.
But honestly, even that is chilly compared to what's out there in the cosmos. The core of our sun, just try to wrap your head around this. It burns at an incredible 15 million Kelvin. The amount of energy and heat raging at the center of a star is it's truly mind-boggling.
So we've gone from the absolute floor of the universe all the way up to the fiery heart of a star. But why does any of this matter? Well, let's bring these huge cosmic ideas back down to Earth and see why temperature is so critical in our world.
I mean, temperature really does govern everything. In our own bodies, just a 1-degree shift can tell us we have a fever. In industry, knowing that iron melts at over 1,500 degrees Celsius is, kind of essential for building our entire civilization. From the cryogenics that power our tech,
to measuring that faint echo of the Big Bang, understanding temperature is the key to understanding, well, pretty much everything.
So if there's one single thing you take away from all of this, let it be this. The universe has a fundamental baseline, a starting point, and that is absolute zero. 0 Kelvin, or minus 273.15 Celsius. It isn't just a number, it is a law of physics that defines the absolute limit of what's possible.
So we know for a fact that temperature has an absolute floor. There is a coldest possible temperature. But that leads to one final, really interesting question, doesn't it? If there's a floor, is there also a ceiling? Is there a hottest possible temperature? Now that is something to think about.